For this next example, we're going to do a financial application. This one says 70 children and 160 adults attended a play. The total receipts were $620. Now the receipts represents the amount of money that the theater brought in. That's how much money they made off of the play, off of the sale of the tickets. It says one adult ticket and two children's tickets cost $7. Find the price of each type of ticket. Okay, so we're going to go through our four-step process again, starting with defining our variables. And we could choose X and Y for these, but I'm going to go ahead and use C for children tickets and A for adults. So I look at that last sentence. It says find the price of each type of ticket. So those are the things we don't know: the price for the children tickets and the price for the adult tickets. So I'm going to set this up. I'm going to have C is the price per child ticket, and A is the price per adult ticket. Okay, those are my two prices. Now, I'm going to again use a table to set up my systems, kind of organize my thoughts. But before I do that, I want to give you a formula that you can use, and this sort of formula generally will work for these problems, and that is that there's some sort of rate. We did the distance, rate, time problem before. When there is a rate involved, you're going to multiply that rate by a number to get a total. And so in this case, we're going to say the price per ticket, multiplied by the number of tickets has to equal some sort of total. Okay, so those are your three amounts that are all combined together. And so I'm going to set up this table. I'm going to set it up with the children in a row and the adults as a row. And along the top, I'm going to have these three quantities: the price per ticket, that's going to be multiplied by the number of tickets, and that's going to be equal to the total. Okay. So now, the price per ticket for the children, we just said, is C, and the price per ticket for the adults is A. Those are the two things we don't know. We do know that there were 70 children tickets purchased, and that there were 160 adult tickets purchased. Okay, so the total amount spent on children tickets would have been C times 70, that's the product, so 70C, and for adult tickets would have been 160C. Okay, so that gives us then the total receipts. If I take the total spent on children tickets and the total spent on adult tickets, it should give me the final total receipts, which were $620. So if I add those together, 70C plus 160C, that should equal $620. That's one of the equations then in our system. The second equation comes from the individual tickets here. This other sentence says one adult ticket and two children tickets cost $7. Okay, so there we have one adult and two children. I'm going to switch those around. I'm going to do two children first. So that's 2C and one adult. Wait a minute, what did I do here? This should have been an A. I don't know why I wrote a C right there. That should be 160A, which means this is A. Okay, that's better. So one adult ticket equals $7. Okay, so that combination is our system, and now I have to solve it. Again, I could use substitution or addition. I'm going to choose substitution for most of these. Usually there's going to be a variable with a 1 as the coefficient. That's the easy one to solve for. So I'm going to go ahead and solve this one for A. I'm going to subtract the 2c from both sides. I'm going to get A equals 7 minus 2c. Again, those are unlike terms, so I cannot combine them. Now I'm going to take this new expression and substitute it in for the A in the first equation. Okay, so I'm going to rewrite the first equation. That is 70c plus 160. The A becomes my new stuff. That equals 620. The new stuff there is 7 minus 2c. Then I need to distribute. Okay, and when I distribute here, I need to multiply 160 times 7. So I'll take that off to the side. If I do 16 times 7 real quick, that's 42. That's 112. I need a 0 on the 160, so it's 1120. Minus, now 160 times 2 is 320. I'm going to combine my like terms, my c's. I'm going to get, what's that, 390 c plus 1120 equals 620. Oh, wait, what did I just do? Oh, that's supposed to be a subtraction, isn't it? Huh, I don't know why I added those. That's a subtraction. Let's ignore that. 70 minus 320 should be, what's that, negative 250? That's better, negative 250. And so I'm going to subtract off the 1120 from both sides. 620 minus 1120 should be 500. So this becomes negative 250c equals negative 500. If that makes sense. Oops. So negative 250c equals negative 500. I'm going to divide by negative 250, and so the c value, negative 500 over negative 250, well, that's half, right? 250 is half of 500, so that should be 2. C equals 2. So that tells me the child tickets are $2. And if the child tickets are $2, and I plug that into my equation here for A, I should get, let's see, we should get A equals 7 minus 2 times 2. 7 minus, this will be 4, would be 3. So my final answer then, to state my answer, is that the adult tickets, well, I'll go children first. Children tickets cost $2 each. Oops, and adult tickets cost $3 each. And that would make sense then, because one adult and 2 children will cost $7 total, right? 3 plus 2 plus 2. And if we put those in to our other equation here, 70 times 2 is 140. And 160 times 3 is 480. 480 plus 140 should be 620. If you were to add that up, it should work out. Okay? All right.